Newton described three laws of motion, and the first of these three are revolutionary. It stated that an object at rest will remain at rest and an object in motion will remain in motion unless acted upon by an external force. The first part seems to make sense, since motionless objects typically don't just start moving, but the second part contradicts much of our everyday experience. When you throw a ball, it doesn't keep moving forever. It eventually stops. For a wheelbarrow to roll, or for your car to move, or for a plane to stay in the air, a constant force must be applied. So, where did Newton come up with this stuff? To understand Newton's first law of motion, we have to understand all of the forces that act on a body on motion.
Our planet is a complicated system, and when we move around in our atmosphere, we experience things like wind resistance and other forms of friction, which is a force that resists motion.
This slows us down.
The ice is very slippery. It is a surface of very little friction. If you gently push a hockey puck, it will glide rather far, much farther than if you pushed it on a table or on the ground.
But there's still friction, so it eventually stops. Now imagine as what Galileo and Newton did, that there is a surface that is completely free of friction.
If you push the hockey puck on this surface, whatever velocity it has after it was been hit by the stick would be retained indefinitely and it would glide forever, unless some other force were to act upon it. This is the kind of motion that can be seen in the vacuum of space. Stars, planets, asteroids, and satellites, these bodies have roughly constant velocity and they never stop moving.
We consider motion in space, where there is no friction and no wind resistance, to be normal motion. It is motion within the Earth's atmosphere that is the special case where objects are subjected to a variety of external forces.
This is why a car needs an engine that is always running because there is a resistance from the atmosphere and friction with the road. But a spaceship can just accelerate to a certain velocity. When the engine turns off, it will cruise at that final velocity without end.
The capacity of an object to resist changes in motion is called its inertia. Force must be applied to get an object moving and again to slow it down to a stop. To fully understand the law of inertia, I created a model that will illustrate and apply this first law of motion. We have here the model where you can see a platform that represents the road and a toy car that will be pushed with a spring mechanism to make it move. Now, applying the concept of the first law of motion, this toy car has its own inertia that resists changes in its states of motion. Without any unbalanced force acting on that object, it will stay at rest and it will not run off the track. However, there is a normal force that acts on the object, which is the gravity, and it is being counterpart with the table that exerts an upward force to the car.
As I turn the wheel on, the spring in the tube will compress, which stores mechanical energy used to run the car off the track. Now, when the mechanical force in the spring is released, it pushes the car from its current position and causes it to accelerate. The energy being stored in the spring makes the car to move, thus an unbalanced force was applied. While the car is running, the friction present on the surface of the track and on the wheels of the car will make the car to stop eventually.
An object will have some amount of inertia that is directly proportional to its mass, a scalar in value measured in kilograms. More massive objects have greater inertia or greater resistance to motion.
For example, this car is approximately 60 grams in mass and this ball is only 10 grams. The ball is lighter than the car, it only requires a small amount of force than the car to make it move. If the ball hits an object, it will stop on impact with a little amount of force needed for it to stop, while the car requires more amount of force to make it stop moving.
In this way, mass is an essential measurement of an object's inertia. As we said, this applies to objects that are already in motion as well.
If you get to a car accident, the force of impact will stop the car, but your inertia dictates that your body will tend to continue moving. This is why we wear seatbelts, because without them, we might continue moving right through the windshield, which wouldn't be very fun.
So, Newton's first law of motion can be summarized as law of inertia, and it tells us that in an absence of a net force, an object will preserve its state of motion, whether at rest or moving in constant velocity.